Hello everyone. In this video, we talk about the first topic in root finding. It's a bisection method. On the textbook, this part of material is in chapter 5. Bisection method is a very simple, robust, and straightforward method. So how it works, assume that you have a function fx, which looks like this. And we first take an interval from A to B. For example, we assume this is A, this is B, right? From A to B, you can see at A, the function of the value of the function fa is positive, and the value of the function fb is negative, and this function is continuous on the interval A to B. So because on one end it's positive, on the other end is negative, so there must be at least one root inside this interval. So this method is about how to find this root. So we first find the middle point of this interval, which is a plus b over 2, and then evaluate the value of this function at this point. So you can see here it's negative, right? So because fa is positive, fb is negative, and at this middle point it's negative. So we are sure that at least one root will be located from A to this middle point, right? But on this half, from the middle point to B, because both of the function values are negative, so we are not sure if there is root, right? So there may be, it's possible that zero root in this interval. So we can remove this one half. And then this middle point will become the new B, right? So from this A to this new B, then we do the same thing. So we find the middle point of this interval, which is A plus B over 2, and then evaluate the value of this function at the middle point. So you can see here it's positive, right? So because the value of the function here is positive, here is positive, but here is negative, so we are sure that at least one root will be located in this half. But in this half, there is no guarantee that there is a root, so we remove this one half. Then you can see the interval is shrinked by one half further, right? So this will be our new A, and this point will be our new B. And then we do the same thing, find the middle point, which is A plus B over 2, and then evaluate the value of the function at this point. So you can see it's positive, so we remove this half, and then continue this method in this half, right? So you can see the interval A to B becomes smaller and smaller, which means you are closer and closer to the root. When you are really close to the root, then we can assume that you find the root. So this is how bisection method works. So the problem we want to solve by using this method is that given a function of one variable, fx, find the value of r so that fr equal to 0. So r will be the root, right? So to make this method work, we need to assume that the function fx is continuous. So what's a continuous function? The continuous function is that when you draw this function, your pen never leaves the paper. So this is a continuous function. So if at some point you need to leave the paper and then draw the other part of this function, then this will be called a discontinuous function. Okay. So the initial requirements, we initially have an interval from A to B, and also to make sure there is at least one root, we require that fa and fb have opposite signs. This is very important. If they both have negative sign or positive sign, for example, from A to B, they are positive, right? So there may be one root, but maybe there are two roots, but it's possible that there is zero root. So we don't, if they don't have opposite sign, we don't use this method because there is no guarantee that you can find the root. Okay. So the iteration process, given the interval from A to B, we define the middle point of this interval as C, and C is A plus B over 2. There will be 3 different scenarios. The first one is that the middle point happens to be the root, which is very unlikely in practice, but it's possible. Then we will stop this method because we already have found the root. Okay, so for this scenario, we have a function like this, right? So this is A, this is B, and the middle point happens to be the root. So when you find A plus B over 2 and the function value at this point is exactly 0, right? Then we can see the root R will be equal to A plus B over 2. Then, everything is over because we find the root. So the second scenario is that FC and FA have opposite signs. Then a root must be in the interval from A to C. So then we assign C to B, okay? So let's see, for this scenario, for example, we have a function like this, right? So this is A, this is B. And we find the middle point here, which is A plus B over 2, which is this middle point called C, right? And FA and FC have opposite signs, right? So FA here is negative, FC is positive, and FB is positive. So the root must be between A to C, right? So we can remove this half and continue search the root in this half, right? From A to C. So when you do the next iteration, this C will be the new B, right? So we always start from A to B and find A plus B over 2. So when you do the next iteration, the A is still the A, but this B is moved from here to here, right? So that's why we assign the C value to the variable B, okay? So the third scenario, which is the last one, there are no other possibilities, right? So in this scenario, FC and FB have opposite signs, and then a root must be inside the interval from C to B. So then we assign C to the variable A. So this scenario looks like this. So we have a function from A to B, and they have opposite signs, so there is at least one root inside A to B. We find the middle point A plus B over 2. So this will be this middle point C. And then we evaluate the value of the function at this middle point. We found that it's positive because FA is positive, FC is positive, FB is negative. So you can see here, FC and FB have opposite signs, right? So the root must be in this interval, so we can remove this half, right? So this C will be the new A for the next iteration, right? So when you do start the next iteration, this will be A, this will be B, and you find the new middle point A plus B over 2, okay? So these are the 3 different scenarios when you do the iteration using bisection method, okay? So let's see one example about how this method works. Consider finding the root of fx, which is equal to x squared minus 3, and we start to find the root in the interval from 1 to 2, okay? So initially we have A, B, then we evaluate FA, FB, right? And evaluate the middle point C, which is A plus B over 2. And then evaluate the function value at this middle point. Then we need to decide how to update, how to define the new interval A to B, right? And we can calculate because every time the interval will shrink by 1/2, so we can check what's the length of the interval right now. All right. So initially, we start from 1 to 2, right? So initially A is 1.0, B is 2.0, and we find FA. FA is 1 squared minus 3, so it's -2. And FB is 2 squared minus 3, which is 1, right? And the middle point, which is 1 plus 2 over 2, so it's 1.5. And FC will be 1.5 squared minus 3, right? So we can see 1.5 squared minus 3. So this will be negative 0.75. Then we can update. So you can see FA is negative, FB is positive, FC is negative. So which scenario is this? So FB and FC have opposite sign, right? So it's scenario 3. So we need to assign the value of C into the variable of A. So we assign C to A. So the length of this interval then shrinked by 1/2. So initially the length, the initial length is 2 minus 1 equal to 1, right? So if you shrink by 1/2, you get 1.5. Okay, so for the next iteration, we start from A to B, but right now the new A is the value of C, right? So which is 1.5, and the B is still the same with the last iteration, so it's 2.0. And if we evaluate FA, which is just the FC in the last interval, the last iteration, so it's -0.75. And the FB is the same because B remains the same, right? Then we check C. So the new C will be the new A, 1.5 plus B, 2, and then over 2. So this will be 1.5 plus 2, and then over 2. So it's 1.75. And then we can evaluate the FC. So FC is 1.75 squared minus 3. So it's 0.0625, right? So we can see here FA is negative, FB is positive, FC is positive, right? So this will be the scenario 2. So FC and FA have opposite signs. So we need to assign C to the value of B. So we assign C to the value of B, right? So the length of the interval is further shrinked by 1/2. So it becomes 0.25. All right. So in the next interval, the A is the same because A isn't updated, so it's still 1.5. But B is updated. The new B will be the value of C, so it's 1.75. So we evaluate FA, which is negative 0.75, and the value of FB, so which is 0.0625, and the value of C. So the value of C will be the new A times the new plus the new B, and then divided by 1/2. So it's 1.5 plus 1.75 that divided by 1/2. So it's 1.625. All right. So the value of FC will be this value square minus 3. So it's negative 3594, negative 0.359. Okay. So FA is negative, FB is positive, and FC is negative. So it's the third scenario. So we need to assign the value of C into A, right? So B doesn't need to be updated, but A is updated by the value of C. So the interval is further shrinked, 0.125. All right, so you can do this again and again until the interval is small enough. Then we can stop assuming that the root is good enough. So we when the value is enough, really close to the root, then we can assume that we find the root. So in the next video, we will talk about the halting condition. So what are the conditions that we can stop the iteration process?